Right, let's orient ourselves to the problem. Here we have an S process. The variables NB initial INT is the substrate doping, and the type is boron. And then there's a flag grow for either growing the screening oxide or just depositing it. So if grow is grow, then a SOX, screening oxide temperature, screening oxide time, right? Then we have SOX R, which is do we remove it or not? No. Then here's the, so that sets it up for the implant. And here we have the energy and dose. And then we have the well drive, temperature and time. Then we have the field oxide, temperature and time. At which point there is a photomask step. And then we diffuse, temperature and time. And then we etch back everything. This is kind of the trick, right? It's a non-self-aligned process. If we look at the commands, it's a little rough. We set up our initial grid spacings. If you want the simulation to run faster, you can set the goals for a little less accurate and set this to grow. But I was getting some weird results, so I kept it here. These are some settings that just come with the tool. You can see how the code is set screen grow. If screen is equal to grow, then grow it, else just deposit it, right? This diffusion, so if you do deposit the screening oxide, you have to just do a little activation of everything. Excuse me. And then you measure everything. I'm not going to get into how things are measured this second. Then you have implant, and then again, we extract some things. It's still one-dimensional at this point. So all I have to do is extract things out of interface. Well drive, same deal. Then we do the field oxide. Again, we can extract just there. Then we have a mask. And here's the this is interesting. So the mask, we just take it from 0 to 5. That's correct. And all the etches are anisotropic. One of the problems is when I put isotropic, the simulation crashed, but I don't know which one. There was a lot of etches here, so that's something that needs to be solved. Is trying to figure out which isotropic etch makes the S device die, and then I take the plots at various steps, right, that we can see what's going on. Even though we use a solid source, I use a spin on glass for this simulation. Then we do our diffusion time. Then we have our photo mask for the, oh, no, sorry. So here's another step. We etch the material, and this is etch time, right? So we're etching the kind of the gate slash field and getting rid of the spin on glass at the same time. Then we have mask 2, and about to go on an airplane here. So this is tickle. I'm going to make up a variable set mass edge expression 5 is the standard. And then what I want to do is add an offset, which should be here. And so then now we can program this string. Oops. All right. Oh, I should. You got to follow this syntax. I got variables to read in. So I usually just go off of my old code. And you could even kind of flag things. But anyway, let's keep it simple. So I'm going to add offset. And okay. Now, just so you know, etch time 0.3 removes the sod and the sod only. It's exactly no over etch. And then we over etch more and more, which attacks the gate oxide, which makes it thinner. So the TOX is the final oxide thickness. And you can see it gets smaller and smaller and smaller. It fails here. I'm not quite sure why. Somehow the contact gets put from the gate and the source, but there's an oxide in between. You can see the N goes down, that's reasonable, and the sub-threshold slope gets smaller. And I was thinking that maybe the offset that I'm using is somehow killing this last one. So anyway, that's a lot of simulations. And these are already done. So I'm just going to run we'll do remaining nodes. Okay. And maybe this will be done after I get to LA. But I'll end the video here.